Okay, in this section 1-9, we're going to be looking at composite functions. And so you can think of that as a way of combining two functions together to form the composition of one with another. Like, for example, let's say f of x is defined to be x squared and g of x is defined to be x plus 1. So the composition of f with g, okay, is going to be, so you would take the g of x part first, which is x plus 1. Then you want to take f of g of x. So I want to take x plus 1 now and plug that into the f function, which means I would want to take f plus 1 and then square it. All right? And so, again, there is the notation for it, and it's read as f composed with g, or most people just read it as f of g. All right? So it's really just taking one function, taking the result, and doing another function right after that. Okay? So again, you've got the notation of the definition. Now, here's something that's also key. The domain of f of g is the set of all x in the domain of g such that g of x is in the domain of f. So if you're looking for the domain of the entire composition, you've got to start by looking at the domain of the first function, g. Okay? When you evaluate that, then you've got to look at the domain of f as well and make sure that it's there, and then take into account the domain of the two composed together. All right? And we'll talk more about that here in just a moment. But just remember, the domain of f of g, the entire composition, is the set of all x in the domain of g such that g of x is in the domain of the next function f. Okay? So let's take a look at an example here. So I want to find f of g of x. And my f function is defined as the square root of x, and my g function is defined as x minus 1. All right? So they're asking me to do two things. I want to find f of g of 2 and f of g of 0. All right? So the first thing that I want to do is I want to see what the composition of the two functions would actually be. So I need to figure out what f of g of x, what that function would look like. So remember, that's the same as finding f of g of x. All right, it's the same idea. And so again, g of x we know is x minus 1, so I want to evaluate f of x minus 1. So I'll take g of x out and put what it's equal to in its place. Now I want to take this value, x minus 1, and then shove it into the f function. And so that would be the square root of x minus 1. Okay? All right. So there's the composition. That's f of g of x. So now I can use that, and I can evaluate the values that they asked me for. Like, for example, they asked me to evaluate f of g of 2. All right, so I need to take that function and then plug 2 in there. So that would be the square root of 2 minus 1, which is the square root of 1, which is 1. So f of g of 2 would evaluate to 1. And also f of g of 0, they have asked me to evaluate. And so when I plug 0 in there, 0 minus 1 is negative 1. All right, 0 minus 1 is negative 1. And square root of negative 1 is undefined. All right, so we cannot take, we cannot find the value of f of g of 0. Okay, and of course, because you're taking the square root of a negative number. And again, this is kind of how the domain of the composition comes into play here that we can take a look at. And so to evaluate this, let's start by looking at the domain of g of x, let's say. So let's start with the first function and talk about the domain of that one. All right, so let's look at g of x. X minus 1. When you're looking here, there are no restrictions. There's no square root of a negative. There's no dividing by 0 here. So really, for just this function alone, I can plug anything I want into g. Negative infinity to infinity. All right? Now, let's look at the domain of f of x. Okay? The domain of f of x, then f of x here is square root of x, and so everything that you plug in here's got to be positive, so the domain of f of x is 0 to infinity. Okay, 0 to infinity. Now we also want to take into account the domain of this entire composition, which is the square root of x minus 1. Square root of x minus 1. Well, the square root of x minus 1, remember the domain for that we've got to keep under the radical, under the square root positive. And so that means x minus 1's got to be greater than 0. So my x has got to be greater than or equal to 1. All right? And so, because if I plug anything less than 1 here, that's going to cause it to be a square root of negative. So my domain of that composition has got to be anything that's greater than or equal to 1. Okay? Now, I can look at these domains of each one of the functions individually and the composition to then come up with what is the domain of the entire function f of g of x. All right, so remember, I've got to start with the domain of g and then take into account the domain of x and then the domain of the composition function that forms as well, because it can be restricted there at any point. And so when I go to take a look at this, well, what can I plug in for g? Anything. So there's no restrictions there. Well, when I get to f and plug into f, I've got to make sure that f is positive. All right? So anything that I take from g that would make that function negative is now eliminated. All right? So keep that in mind. And now we're really skipping down here to the composition of the two, because that takes into account both of them together, right? And so now when I'm looking at the composition of both of them together, I see that I can only plug in something greater than or equal to 1. Okay? So that eliminates anything that's below 1 from that original domain. So you've got to really look at both of these before you decide on what your answer is. So my answer here is 1 to infinity. That is the actual domain of the composition. And of course, when we look at this domain, we can now see why 0 didn't work. It's outside of the domain of the composition. All right? So remember, the domain of the composition is the set of all x that's in G, such that G of x is in F. So you've got to make sure that you take into account all domains and see what could possibly be restricted there. All right? So keep that in mind as you're moving forward through these types of problems. Let's go to the next one. And so here they are giving me again, they've defined two functions, f and g. And the first thing they want me to do is they want me to find, evaluate f of g of x for x equals 0 and 1, and then reverse it, g of f of x at 0 and 1. And remember, the answers may not be necessarily the same because you're doing it in a reverse order. All right, so let's see what this would look like. So the first thing I want to do is I want to find f of g of x, and then I can plug in and evaluate. So I want f of g of x. And remember, that is the same as this notation, f of g of x. Okay? All right, so let's see what it evaluates to. So I want f of g of x. Well, what's g of x? G of x is 4 minus x squared. Okay? And now I can take f of that, so I can shove this part now into the the f function, which means in place of x, I'm going to put this, 4 minus x squared, and plus 2. All right, so with a little simplification, I can now see that the composition is going to be negative x squared plus 6. All right, so there's my composition. That's f of g of x. Okay, so the first thing that they asked me to find is f of g of 0, f of g of 0. And so if I plug 0 in there, that's just going to evaluate to 6. And they also asked me to find f of g of 1. So if I plug 1 in here, that's 1 squared. Negative 1 plus 6 is going to be 5. All right? So now they also asked me to reverse it, find g of f of x. So let's figure out what that's going to be. So I need g of f of x, which is the same thing as finding g of f of x. So this time the difference is I'm going to evaluate f of x first and take that result and plug it into g of x. So now I want g of, well, what's f of x? F of x is x plus 2. So now I need to take that and plug it into g. And so when I take x plus 2 and plug it into g, I'm going to get 4 minus x plus 2 squared. So I'm taking this and shoving it into x of the g function. Okay, so again, to get the full composition, I now want to simplify this down. So that would be 4. And that's going to be minus. And I'm going to go ahead and square this out first. So I need to do x plus 2 times x plus 2. So I'm going to use the distributive property. X times x is going to be x squared. X times 2 is 2x. But then I have another 2 times x, which is 2x. I'm going to go ahead and add that together and make 4x. But if you need to multiply all that out without skipping any steps, you can feel free to go and do that. And then 2 times 2 is 4. All right, so we FOILed that out. And so now we can kind of finish it with negative x squared. Don't forget to distribute that negative. It's going to change the sign of every term in the parentheses. And so I've got my x's coming here next, which would be minus 4x. And 4 minus 4 is gone. And so there's your composition of those two functions right there. All right? Now let's evaluate what they asked me for. They want me to find g of f of 0. So if I shove 0 in there and 0 in here, then g of f of 0 is going to be 0 all the way around. And then so now let's go g of f of 2. Nope, not 2, it's 1 that they asked me for. So I'm going to plug 1 in there now and see what happens. So if I plug in a 1 there, right, that's going to be negative 1 squared, which is negative 1. And that's going to be minus 4 times 1, which is 4. And now, so I would say that that evaluates out to a negative 5. And notice they're not the same. Okay? So if you reverse the order in which you do the composition of the functions, you will not, many times, sometimes you might, but typically you will not get the same answer every time that you evaluate those things. All right? And just quickly, if they had asked me for the domain, say, of f of g of x, well, the domain of g of x right here, all real numbers. The domain of f of x is all real numbers. The domain of the composition is all real numbers. And so if they ask me for the domain then of f of g of x, then the domain of that would be all real numbers. Okay, so that's one that where the domain's not restricted at all. Okay, let's move into the next one. And so on this one, they're asking me to find the domain of f of g for these functions. All right, so again, the first thing I want to do is see what the composition looks like. So I want to find f of g of x, which remember is the same as f of g of x. All right, so let's see what the composition looks like. It's going to be f of g of x. I'll take that and plug it in first, which is going to be the square root of 9 minus x squared. So now I need to take that and plug it into the f function. So I'm going to take this and plug it into x here, which is going to leave me with the square root of 9 minus x squared, close. That whole thing now is going to be squared, and then minus 9. All right, so let's do a little bit of simplifying here and see if we can come up with the composition, what it looks like, in a little bit better form here. Remember, square root and squared, they're opposite operations, right? And so they undo each other. So the square root of 9 minus x squared would just give me 9 minus x squared. All right, so that falls out nicely, and then we've got a minus 9. And so really, negative x squared is going to be your composition here. All right, now, okay, they didn't ask me to evaluate anything. They just want to know what is the domain of f of g of x. Okay, so again, let's take into consideration the domain of g of x first. That's the first level, the base level. All right, so we want the domain of g of x. Well, remember, we've got a square root. We can't take the square root of any kind of a negative number here, right? And so what that means is, when you're looking at this, I have to make sure that 9 minus x squared is greater than 0, right, or equal to 0. And so when I go and solve that, I can, let's see, move this over here to the other side, take a look at what we got there. And so I'll have 9 is greater than or equal to x squared. Then when I take the square root of both sides, then I'll have plus or minus 3. Then my x has got to be less than or equal to plus or minus 3. And so what that means is anything bigger than 3 or negative 3 that I plug in here is going to make my me take the square root of a negative number. So like that, for example, if I plugged in 4, that's 16. 9 minus 16 would be a negative number. So my domain here has got to be between negative 3 and 3. All right? Between negative 3 and 3. Okay, so here's kind of what we're looking at. Now I want to take into consideration the domain of f of x. All right, I want to take into consideration the domain of f of x. Now, when we're looking at f of x, there's really no restriction on the domain here at all, right? Because there's no square root of a negative dividing by 0, so the domain there is really from negative infinity to infinity. All right, let's take a look at the domain of the composition now, which is this, the domain of negative x squared. And really, if you look at that, there's no restrictions on the domain there, because I can plug anything I want in there. So if I want now the domain of the full composition, f of g of x, then I've got to take into consideration, okay, what are my restrictions? Well, I'm restricted by the very first function to be negative between negative 3 and 3. Okay, anything outside of that range won't even work for g. Okay, so anything outside there is eliminated, and so there's nothing else that's any more restrictive than that. So the domain of the full composition is from negative 3 to 3. So here's what I want you to kind of remember. If I plug in anything outside of that, the composition won't evaluate, right? And so, like if I plugged in negative 5, let's say. Negative 5 squared is 25, and 9 minus 25 is a negative number. Take the square root. You can't even get g of x of that to plug back into the f of x to get the full composition. And here's why, this is another reason why it's important to look at all of the domains to find your restriction. Because if I were to just look at the composition by itself after we're done, oh, well, that looks like all real numbers can go in here. Well, yes, this function alone. But remember, to get to here, you're doing a composition, which means you've got to start here, right? Take what you get there, plug into here, and then get a value. Well, if you can't even get past g of x, there's no way that you're going to be able to have something to plug into f of x. And so that's why it's important that you can't just look at the end result to get the domain of the entire composition. Yes, if this was just the function by itself, the domain would be all real numbers. But since this is a combination of two previously defined functions, you've got to make sure that what you're plugging in is in the domain of every step along the way. All right, so that's what you've got to be careful of. So in this case, with these two defined functions, the domain of f of g of x is between -3 and 3. All right, so keep that in mind. The important thing is you cannot just look at the end result and use that domain to get your answer for a question like this. So make sure that you're aware of that. And now you've got a quiz waiting for you in Canvas.